Hello class, and welcome to the week 11 lesson recording. So as you can see today we're going to talk about pre and post conditions, static variables, non-static methods, static and non-static methods, variable scope, and dependency diagrams. So just a lot of little things to kind of tie everything together, kind of pull all the last little concepts into the course. All right, so precondition. So precondition, as it kind of indicates, it's something that must be true before a method executes. So this is enforced data validation inside of the method. We haven't gotten into a lot of data validation in 111. This is something that will be addressed in a great amount of detail in 121. So you'll really get into doing a lot of data validation, but we have done some data validation. So an example might be changing a gender. So let's say we have a student that we're storing, so we have a student class and we want to have the gender stored for that particular student, and we want to change their gender. So for a birth gender of a student, the gender valid fields would be male or female, and so if this is data type character as indicated here, then you could accept in a value of either M or F, but it could be capital or lowercase m, capital or lowercase f. So the precondition beforehand is the gender that you're receiving in as an explicit parameter must be of the value M or F, either upper or lowercase. Okay, and so here's an example of this precondition where we check ahead of time and we make sure that the gender is equal to either M or F, upper or lowercase, and if it is, then we set the gender, and if it's not, then we're not going to set the gender. So in this particular case, this method returns a Boolean value of either true or false. True if it was able to change the value of the gender, and false if it was not able to change the value of the gender. So this would be a precondition, which is your data validation, checking things before an action takes place in the method. Okay, another example here is compute the days. We have a date data type, which is start, and then another date data type, which would be end. So this would be computing the days between the starting date and the ending date. So if we look at this, consider for a moment what precondition should exist in this particular state. And so the precondition would be that the start contains a valid date and the end contains a valid date, so we would expect those to both be valid preconditions, and also that the start date comes before the end date if we're computing the number of days between these two dates. Okay, so validating this, we would obviously make sure that the start date is a valid date of some sort, and we might have certain criteria for that, like maybe if it's information that takes place after the student, like we're computing the number of days it took the student to earn their degree, we would expect that both the start and the end date would be after the student was born, right? So only a valid date after the date the student was born. There might be other things that you're checking, and so you would have other qualities to validate the date, and then likewise that the start date is less than the end date. So those would be two things that you could validate before you actually compute the number of days between the two dates. Another precondition might be is minor, where an age is coming in. So the precondition, we would expect this to be a valid age. So it should be 0 or greater, right? We wouldn't want any negative ages. So we could validate that by checking to see is the age less than 0, and if it is, it's not valid. Otherwise, we can determine whether this is a minor or not based upon the age value. Okay, so preconditions are things that you're going to check before you take an action. A post condition is something that is true after the method executes. So a precondition would be before the final purpose of the method. So it's part of the method, but it happens before the actual value or before the actual meat of the method executes, I guess. And the post condition is what's true after the method completes execution. So we've actually been testing post conditions all along in our course through our labs and through the different mini labs and your different homework assignments. And we've been doing that with test-driven development. And each one of our assert statements checks what's true after the method has completed execution. So for example, in our set gender, when this completes, the gender should contain the new value, or it'll return a value of false, meaning that it cannot modify the particular gender. So here, if we have public Boolean set gender with an explicit parameter of in-gender, we could provide it a valid gender of M. You know, we've created our object calling our constructor, right? And then we call the set gender on that particular object with a value of M. We would expect that it would return a Boolean value of true, and we would also expect that if we retrieve the gender, it's now equal to M. So this is a post condition. True is returned, and the gender is now changed to contain a value of M. And we would want to repeat that for all possible genders, since we just have the 4 possibilities here for this particular method. And we would also want to test for an invalid gender, maybe giving a Q or a T or an R or something like that, and make sure that it gives us a false and that the gender is not modified. Okay, so these would be valid post conditions. Another example of the post condition is computing the days, again with our start date and our end date. What post condition should exist? We would expect that we would have the difference between the 2 days. So let's say we started with a January 1 and January 31st, and so there would be 30 days between those 2 dates, right? And so we would test that particular condition. Boolean is minor with an age. So we would expect that if we give this a valid age, if we give it a negative age, that it won't return anything, it'll return false, right? If we give it a valid age, that if the age is 18 or less, that it would return true. And so we would want to give it an invalid age, an age that's not a minor, and then an age that is a minor in order to thoroughly test this post condition of this is minor method. Okay, so those are pre and post conditions. So again, a precondition is what must be true before the whole purpose of the method executes, and a post condition is what must be true after the method completes execution. All right, static variables. So we talked about a static variable way back when we were talking about constants, right? And so we had mentioned that a static variable actually belongs to the class. It does not belong to the individual objects. Okay, so by that meaning, really a constant, it makes perfect sense to make that a static variable where you only need one instance of that particular variable. So maybe you have a constant that's the value of a quarter equals 25 cents, and you attach that to the class. All of the objects have access to that variable from the class, but there's only one instance stored in memory. Okay, so all the objects have access. All can access the value. That last one, all can change the value, is only true if it's not a constant. If it's a constant, the value cannot be changed. Now, an example of a static variable that belongs to the class that would not be a constant might be, let's take a student ID generator type of a class, okay? So every student coming into Franklin has an ID assigned to them. And so maybe we have a utility class called ID generator, and it actually has a static variable in it that contains the last ID that was generated. So when we add another student, we would go out there and say, okay, that was the last ID. We're going to add 1 to it. That's now this student's ID, and we bump it up by 1. So it kind of keeps track of the last student ID that we used. So that would be a great example of a static variable that was not a constant. Okay, and down here we have private static integer last assigned num equals 4, and then this could be updated by any object of that class. Okay, here's another example of a static variable. We have public static integer customer number equals 0. And then we have private int cusnum. So here we've created customer number equals 0, and anyone can then access this particular number and update it. So this cust number equals plus plus customer number. Remember the increment, if it exists before a variable, then the increment occurs first. So originally this had a value of 0. We add 1 to it. It now contains a value of 1. And then we assign our custom instance variable the value of 1. And this also is updated to contain a value of 1. So this would be another example of a static variable keeping track of a customer number. And the static variable would belong to the class, not to the object. This one would belong to the object. This one would belong to the class because of the keyword static. There will only be one instance of that variable stored in memory, where this particular variable would belong to each object. So there would be one instance for each object. Okay, but this can be accessed by all objects and modified by all objects as well. Okay. So again, it belongs to the class versus belongs to each object. You can also have a static method, and we've actually been dealing with this a lot throughout the course. So if you were to take a look at your main methods and all those demo or driver programs that we've been creating, those have been static methods. And this, again, is a method that is not invoked on an object. It belongs to the class. It does not belong to the object. It cannot be called from an object. It can only be called directly from the class. Okay, and so you may have gotten some errors as you were working on your different projects, and maybe you were doing a main method and then you got trying to call the non-static variable from a static concept or something like that. Well, that's where this all comes in, that you had a static method and a non-static variable or vice versa, and you really needed to be consistent in those. Okay, so here we have a utility class, math.absolute. An object is not constructed. Math tells the compiler this is the name of the class, but the absolute method is a static method. So you're not constructing an object, you're not creating a math object here, but you are able to call this static method absolute and use it within your programs. Okay. So that's it for static. We're going to talk about dots, and we've been doing dots all along, right? Dots are used as separators, so they're used as separators between package names, between package and class names, between class and inner class names, between classes and instance variable names, and objects and methods. So dots, periods, however you want to use them, we have been using those all throughout this course. So for an example, java.lang.system.out.println sub x. Okay, so when you're trying to figure out what is this a class, is this a package, is this a method, is this an object? Me personally, I like to start with the parentheses. Are there parentheses? Because you know a method always has parentheses, right? They may be empty, meaning there's no explicit parameters, or they may have values in them, meaning there are explicit parameters, but a method will always have the parentheses. So if you can find those parentheses anywhere here, then you know what's right in front of the parentheses is a method, okay? And then a method is always, well, it's called either from an object or it's called from the class. If it's a static method, it's called from a class, right? So how do we know that? So we know this is called from something. We have a dot, so it's being called from something. And here we've got out. It's got a lowercase letter, right? So lowercase by Java is an object. Uppercase by Java is a class. So we can look at this out and we would say that would be an object. There's a dot in front of that, and so we can look here, system, and we can see a capital S, so we're going to assume a class because that's the Java naming convention. And then we have a java.lang, which is going to be your packages in front. So let's take a look at another example. Here we have import java.util scanner, and then down here we have a bunch of code. We have a constructor creating a scanner object, we're printing something out, we're accepting input from the console, printing something out, accepting input, doing a local variable here where we're multiplying and then printing something out all along. So if we use our periods or our dots to help us figure things out, again, first we're going to look for those parentheses. So first look for parentheses. All methods have the parentheses, right? So the one exception is your constructor is technically not a method, so you would eliminate those, but everything else. So here we have the parentheses for the print line, for the next line, for the print line, for the next integer, and again for the print line. So we would identify our methods by looking for those parentheses. This is a constructor, and we know that because of the format. Scanner in equals new scanner. Okay, the class name and the constructor name are the same, and the constructor name is in caps where your method name would be in lowercase. Next, look for the classes. So classes, Java convention is that classes start with capital letters. So here we have scanner, system, string, and so on. Then you're going to look for the objects. Method are called from objects. They can also be called from a static class. So, or if they're a static method, they could be called from a class. So you're going to look directly in front of each one of those methods to see, does that item start with a lowercase letter or does that item start with an uppercase letter? An uppercase would indicate a class, which would mean it was a static method. Lowercase is an object. And then, of course, we know for our constructor that we are creating an object. So here you can see our objects. Now I did put this item inside of the print line. It's in quotes. This is a string, a literal here, and strings are objects. So that would be an object as well. So all the items in green are objects. Okay, so our purple are our methods, blue are our classes, green are our objects. And then last, you can look for packages. So you'll kind of look at import statements, java.util, and that would be our packages. So this is how you can look at a statement and tell what is going on. What is your method? What is your object? What is your class? And what are your packages? Okay, last, the concept, variable scope. So we have been talking about local variables, and up to this point we've been talking about local variables as existing within a method, that they come into existence when the method begins and they cease to exist when the method finishes, right? And that is definitely a true statement, but it actually goes a little bit further. The scope of a variable is actually defined by those curly brackets. So it can definitely be defined within a class if you have an instance variable defined with the class. It can definitely be defined within a method, so wherever those curly brackets are in the method, but it can also be defined within a loop. If you were to define a variable, like actually define the variable with the data type inside the curly brackets of a loop, then the scope of that variable is inside of that loop only. It does not exist prior to the loop, and it will not exist after the loop completes. It is only exists within the curly brackets of the loop. And the same with an if statement. If you were to define a variable inside of the curly brackets of an if statement, it exists within that if statement only and will not exist after the if statement finishes. It's discarded when the if statement finishes. Okay, so here is an example. So we have a class called dog kennel, and the purple shows you the scope of the class. So we have our purple opening curly bracket and our purple closing curly bracket. So we're looking for variables that are defined at the curly bracket level. So immediately after this curly bracket, we have these two variables, an array of type dog, and then a next position variable. These would be instance variables. Their scope is the entire class, so they're available to the whole class. They're defined at this curly bracket level, and so they're available for the whole purple scope. Next, we have this method called getDogs. And inside of it, we have an explicit parameter. We also have the string variable output. So we're looking at things defined within the blue curly bracket, so that's the blue scope, which is the scope of this entire method. So an explicit parameter is really a local variable defined for that method only. So in, age, and output are both defined at the blue curly bracket level, and so the scope of them is for this entire blue curly bracket. So they're not available up here in this where it's purple only, they're only available in the blue scope. Next, we have a for loop here, and that's defined by these green, so it has a green scope in this particular example. Here we are defining the variable I right here in the for loop, so I is only going to be available in the green scope. It's not available up here because it didn't exist yet. It's defined at the point where the for statement begins, and then likewise we have this temp dog defined in here, and this is also defined within the for loop, so it has a green scope and it's not available where the scopes don't overlap. So where the green and the blue and the purple overlap, that all has green, right? But where it's just blue and no green, those would not exist. And then inside here we have an if statement, and that's defined by the yellow. So inside of that we actually define this dog years variable of data type double. The scope of dog years is within this if statement, the yellow if statement only. So it doesn't exist up here or actually anywhere above where the yellow starts or anywhere below where the yellow ends. It exists in the yellow only. So the variable scope, we were thinking of them as being local variables to a method itself, but it actually can be local to the if statement, local to a for statement, or local to a method as whole, or local to a class as whole as well. Okay. There is one more thing, dependency diagrams. So we've actually been looking at dependency diagrams all along. When you pull up BlueJ, what you see is a dependency diagram. Now, dependencies between classes, so this would be your coupling that we talked about last week. So coupling or dependencies, they're shown by a dashed line with the arrow pointing from one class to another. So it goes from the class and points to the class that it's dependent on or coupled with, okay? So for instance, if we have a customer class that incorporates an address class as well, you would have a dashed line from the customer pointing to the address. All right, and here's how that looks. So the customer is dependent upon the address. The address does not need a customer to be a valid address, right? An address is an address by itself, but the customer does need the address in order to provide us information about that customer. So we have a dashed line going from the customer to the address, and you can see our arrow pointing down here at the address. Okay. So assume you have a home business. You want a system to keep track of customers, product inventory, and sales. We would have sales up here, and sales would be dependent upon a customer. So we have our dashed line coming from sales, and you can just make out the arrow down here pointing to the customer, and then also products. So a dashed line coming from sales down to products, and the arrow down here is pointing to products. So the sales class would be dependent upon both customers and products. That those two things combined together is what makes up a sale. All right, and our last example is assume you have a library that has a catalog of all your books, DVDs, CDs, and so on. You need to know all of your customers. You need to know which of your items have been checked out and by whom. So here we have a rental class that ties together a customer with the item that they've checked out and also includes the catalog so it can keep track in the catalog what has been rented, what hasn't been rented, right? So the rental class is going to be dependent upon both the customers, the items, and the catalog. And then we have a catalog that is dependent upon the items because the catalog is going to list all of the items that are available and then show their status. Either they're rented or they're not rented or when they're due back, that sort of thing. And so this would be an example of another dependency diagram. All right, and that brings us to the end of the week 11 lesson and also to the end of the lessons for Comp 111. As always, if you have any questions, please do not hesitate to ask.